Alrighty guys, so today we are going to start Unit 3, which is about parallel lines and a little bit about perpendicular lines, and we talk about angles and triangles and polygons later down the road, and we talk about graphing lines and stuff, but that all comes later. So for today's lesson is going to be about properties of parallel lines. Okay? So remember the definition of parallel. It's two coplanar lines that never intersect. So if I just hand drew an example, we would say that line L is parallel to line M. Those two little bars right there mean parallel. And on the actual parallel lines, I can put a notation that lets my brain know that, hey, these are parallel. And it looks like little arrows. Okay? So if two lines have one arrow each on them, that means they are parallel. Okay, and then you could see it where there's another set of lines like this. Let's call those J and K. To tell you they're parallel, we would put two sets of arrows. So we would say J is parallel to K. But anyway, just to review what parallel is, basically it's two lines that never cross, okay? You all know that. Now, a new word you're going to see is a word called a transversal. A transversal is a line that intersects two coplanar lines at two distinct points. Okay, so I made this little picture here. Okay, we've got lines J and M, and they are being intersected by this line T. This T is the transversal. Okay, so it intersects the line there and there. And what's special about a transversal is that when you have it intersecting two lines, you're going to get 8 distinct angles. Okay? And then, as we'll find out on the next slide, these angle pairs have relationships with each other. They have certain names, but we'll get to that in just a second. Okay? So basically, all this slide is for is what a transversal is. You know, it's the one intersecting. All right. There's a lot going on here. We're going to start at the top with this little box that is named that transversal. Okay? And it's very important, especially for later on down the road in this unit. You have to be able to name a transversal. Okay? And how you do that is you look at the pair of angles that you're given. Okay? So let me show you what I'm talking about. This first line, we're going to talk about angle 1 and angle 1 and angle 12. So let's go put a mark. Angle 1 is right there. Angle 12 is right here. So when I do this, I ask myself, which one of those lines is both of those angles on? Okay? So if we look at angle 1, I can see that it's a part of this line J, a part of this line L, and a part of this line. That's it, J and L. Okay? Angle 12, it's also a part of L, and it's a part of K. Which one of those is in common? It's this line L. It's the only one that both of those lines fall on. So we would say line L is the transversal. Okay? Now we got a different pair. So let me erase this green. 3 and 6. So we got 3 and 6. Which line do they both fall on? Looks to me like it's this one, line J. Okay, and I know that because both those angles are on that. I can find them on that line J. Okay, it really is just kind of a circle the two angles you're talking about and step back for a second and then just look at which line they fall on. You do what I call sit and stare. You just sit and stare at it for a minute. 7 and 15. So we got 7 and 15. Excuse me. What's the one line they're both on? Looks like this one. So that would be line M, as in M&M's, like the candy. Okay, and then last one we can talk about 12 and 14. And that would be line K. Right? Again, it is super important to be able to recognize which transversal two angle pairs lie on, because you're going to be asked how to do that later. So let me just scoot this a little bit. Okay. Now we got these boxes, and they have big, bold titles at the top. These are the 5 major types, but actually it's 5. It's all 5. It's all 5 types of angle relationships that happen when you have two lines being intersected by a transversal. Okay? And they are all going to be related to their location on the transversal. Okay, and as we go, I'll try and explain what that means, okay? And of course, I'll tell you what all these names are. So the first one we're talking about is corresponding angles. And the easiest way I can describe corresponding angles is they're in the same spot, if you will, but on in different locations on the transversal. Okay? So if you've been in the building before, my room is upstairs next to Miss Amundsen. I'm in room 227. Okay? Below me is the cafeteria, or at least a portion of the cafeteria. So I could say that my room and that portion of the cafeteria are corresponding because we're in the same spot location, just on different floors. I'm on the second floor and the cafeteria is on the first floor. I hope that makes sense. Let's look at some examples. And all I'm going to do, guys, is just pull a few out because with this many lines crossing here, you've got a whole bunch of examples. Okay, now I'm just going to pick out a few. Let's start by looking at this first line, L, right here. I'm just going to highlight it so we can look at it. We're going to call that our transversal. So we're going to look at lines J and K, and their transversal is this L. So what are some corresponding angles? Well, the first pair I noticed, we're going to say angle 1 and angle 9. Angle 1 and angle 9. And you can kind of see what I mean by that. They're on the same side of this transversal line, and they're both in the upper left-hand corner of their neighborhood. What I'm calling the neighborhood, guys, is that this group of 4 angles right here. 1, 2, 3, 4. 9, 10, 11, 12. Okay? 1 through 4 is a neighborhood. 9 through 12 is a neighborhood. And 1 and 9 are both in the top left corner. They are corresponding. Okay? Another pair would be angle 2 and angle 10. And you could list the other ones there for that green line too. Okay? Let's look at I'm going to erase this and get my dots over here. Now I'm going to apologize in advance right now. This video is probably going to be a little bit longer just because there's so much I have to talk about. So if you feel the need to pause it and then do something, that's fine. But do watch the video in its entirety. Okay. Now, speed up a little bit. Now we're going to let J be our transversal. Okay, so now we're going to look at lines L and M, and they're going to enter, their transversal is line J. So our neighborhoods now are 1 through 4 and 5 through 8. Who's corresponding here? Well, 2 and 6 correspond. And now you might be thinking, well, are 10 and 6 corresponding? Because I've got up here in green, angle 2 and 10 were corresponding. Remember, the green was a completely different transversal line. Okay, and the red's a different one too. It's all dependent on which transversal you're looking at. More than likely, you're probably just going to have one transversal to look at. I copied this from some other place. So just know that all these relationships I'm pointing out here at the bottom are going to be relative to the specific transversal you're talking about. Okay, so I'll even label that. Like these two were when L was the transversal. Let's do another red one. We would say 3 and 7. They're in the same location in their neighborhood. So we could say angle 3 and angle 7. And these were when J was our transversal. Okay? I hope I'm not confusing you with the amount of lines going on here. But if you watch this video and you're confused, please let me know, and I'll try and explain it better. All right? Now let's move on. That was corresponding. So corresponding, remember, is kind of like same location in different neighborhoods in your grouping of 4. Okay? Now we're going to look at alternate interior angles, and you have to understand what both of those mean. Alternate means they're on opposite sides of the transversal line. Okay? And then interior means those angles are inside the two angles they're inside the two lines. So let me show you what I'm talking about. Let's do black. So let's go back to, we're going to let, if I can draw a straight line, that would be really great. We're going to let this be our transversal again. Okay? So we're going to look at J and K as our two lines being intersected, and L's the transversal. So if you can, ignore this other side where 5 and 13 are. Look at just this side where I've got the black line. The interior space you're talking about is are these angles in here. Okay? It's those 4 inside. They are inside lines J and K. That's what I mean by the interior thing, okay? They're inside those two lines. And then alternate means they're on different sides of the transversal. So one pair we could say angle 2 and angle 11. Then the other pair is angle 4 and angle 9. Okay? So these are inside the two lines, the two main lines, and they're on opposite sides of the transversal. Okay? Let's look at L now. Or I'm sorry, excuse me, M. We're still going to talk about J and K as the two main lines, but now we're going to look at M as our transversal. This time, those are your interiors because they're inside. And then the opposite ones would be, or alternate would be angle 6 and angle 15, and then angle 8, and angle 13. Okay? And then, of course, you could do it the other way for the other lines, but I'm just going to do looking at L and M as transversals. Now, I'm going to leave that there. I'm going to leave part of it. Okay? So our next grouping of angles is going to be, we're still alternate, but now we're going to talk about exterior. So let's go back and look at our transversal here for L. So we still want to be on opposite sides of that transversal line, but now we want to be outside the two main lines. So this time we want to look outside J and K. So we got angle 1 and 3, 10 and 12. Those are your exterior angles in this specific example, okay? And then on the ones on opposite sides, we would say that's angle 1 and angle 12, and then angle 3 and angle 10. Okay? Let's look at the other. Let's look at M as a transversal. Your exteriors are 14 and 16 and 5 and 7. And now we want to be on opposite sides. So if we start with angle 5, his pair is going to be angle 16. Then if we go to 7, that will be angle 14. Okay? So now, as a review real quick, the word alternate means they're on opposite sides of your transversal line, whichever one you're talking about. Interior means they're inside the two main lines. So for us, it was J and K. They're inside J and K. Exterior means they're the angles outside of J and K. All right, I'm going to erase this. Now, I'm still going to I'm going to keep those transversals. So I'm going to keep referencing those. So now we switch to this fancy word called consecutive. I don't prefer that word myself. I prefer what's in parentheses there, same side. But now, what that means is we're going to look at the angle pairs that are on the same side of the transversal line. Okay? So if you see consecutive, just think same side. And that means we're looking at the angles on the same side of our transversal line. Okay? And now we're going to talk about the interior. And again, the interior means it's those angles inside your two big lines. So if we're talking about J and K, we're going to look inside on this black. So this is your inside angles for the black. And now we want those angle pairs that are on the same side. Okay, so we would say angle 2 and angle 9, and then angle 4 and angle 11. Okay? So those are on the same side of the transversal line L, and they're inside J and K. If we think about the red over here, this is the inside angles, your interior angles. Your same sides are going to be 6 and 13, and then 8 and 15. Okay? So consecutive means on the same side of the transversal. Interior means they're inside your main lines. And now the last pair, put my transversals back. Okay, so we're still consecutive. We're on the same side of the transversal, but now we want to be outside those two main lines. So that would be those two and those two for the black. And so your same sides in black are going to be angle 1 and angle 10, angle 3, and angle 12. Okay, if we switch to red, there's your exteriors. Your same side reds are going to be 5 and 14. Forgot my angle sign. And then angle 7 and angle 16. Okay? Okay, it is super important that you understand this concept that I'm talking about on this slide here. Okay, you've got to be able to name a transversal. So that's what we did first. And then you have to know these angle pair names. You have to know what corresponding angles are. So I would say they are in the same location but different neighborhoods. Okay. Your alternate interiors are on different sides of the transversal line and they're inside the two major lines. Alternate exteriors are outside the two major lines and they're on different sides of the transversal. Same side interior, they're on the same side of the transversal line and they're inside your two major lines. And then your same side exteriors, they are on the same side as the transversal and they're outside the two major lines. All right. Now, all this was in reference to the general format of two lines intersecting with the transversal line. Okay, our focus is going to be when the two lines being intersected are parallel. Okay, and there are several theorems and a postulate that go along with all these angle pair names at the bottom. So let's look. So the first thing is the corresponding angles postulate. If a transversal intersects two parallel lines, then the corresponding angles are congruent. And so they're telling us angle 1 is congruent to angle 2. So in this diagram, we're talking about L and M. Those are the two lines being intersected. How do I know they're parallel, Mr. T? Well, see these purple arrows? That tells you they're parallel. This T is the transversal. And they've just picked out 1 and 2 and said, hey, those are corresponding. And they are. They are in the same location in their respective neighborhood. So angle 1 is in the top 4. Angle 2 is in the bottom 4. They're both on the top right side, so they are corresponding. And let's say angle 1 is 30, angle 2 is 30. Now, these are theorems. So if we had time in class, we might actually prove these, but we're just going to use them. Alternate interior angles. If a transversal line intersects two parallel lines, then alternate interior angles are congruent. So in this diagram, we've got angles labeled 1, 2, and 3. 1 and 3 are the alternate interior angles, and so they are congruent. That will be the same measure. And if we talk about same side interior angles, that would be in this case 1 and 2. They're no longer congruent. Okay, they are supplementary, which means when you add them together, they would equal 180 degrees. So if angle 1 is 80, angle 2 is 100. Think about it that way. Okay, so flash review. Correspondings, congruent. Alternate interiors, congruent. Same side interiors, 180. They are supplementary. Let's talk about the exteriors. Your alternate exterior angles, that would be 1 and 3 in this diagram over here. They would still be congruent. Right? And then your same side exterior angles, they are also supplementary, just like your same side interiors were. Okay? So here's what I tell myself. Let me write it down here. You got two options when you're talking about these parallel lines. You've got when they're congruent and when they're supplementary. If you're talking about corresponding angles, those are congruent. Your alternate interiors are congruent. Your alternate exteriors are congruent. Supplementary. Your same side interior and your same side exteriors. Okay? Here's a trick to remember that. Supplementary starts with S. Same side. Your S's go together. All your same sides are always supplementary. Means that equals 180. The rest are congruent. Okay? And I cannot stress enough, guys. I cannot stress enough. You have to know these, okay? You need to commit these to memory. Because if we were in class, I could just pop off and say, hey, what are corresponding angles? And you would have to say congruent. Okay, you've got to know what these are. Now let's use them. Okay. So we're going to find the measure of angle 1 and angle 2, and we're going to justify our answers. Okay, and they will always give you at least one angle measure. Okay, because in these parallel lines things, if you know what one angle is, you can find all of them using those relationships we just talked about. All right. Now, we have to find what the measure of angle 1 is, the measure of angle 2. All right, and they told us this one down here is 75 degrees below 2. Well, I know that 75 and this angle 1, they are corresponding. Okay? They are in the same location, that is the bottom left corner, in their different neighborhoods. Angle 1 is up here in the top neighborhood, and 75 is down here in this bottom neighborhood. They're in the same spot. So we would say these are 75 degrees. Angle 1 is 75 degrees. Okay? Now, I have to justify. I have to give a reason. I would say corresponding angles are congruent. That's literally all your justification is. Okay? So let's label that. Now, what's angle 2? Well, if you notice, angle 1 and angle 2, they are same side interior angles. Right? And I know that those two have to add up to 180. So in other words, 75 plus angle 2 has to equal 180. So with a little subtraction, we would say angle 2 is 180. Subtract 75. Well, what's that? Let's figure that out. I have to grab a calculator because I can't do that in my head. I should be able to. Let's see. 180 subtract 75. There we go, 105. So this is 105 degrees. Okay? What did I use to get that? Same side interiors are supplementary. That's literally my justification. Okay, and I'm abbreviating, and you can abbreviate too. Just abbreviate enough so that I know what you're talking about. You're not just pulling something out of thin air. Okay? That's number 1. Let's look at number 2. Now, notice that this time our parallel lines are kind of running in a more vertical-ish direction. So what you might have to do is kind of like crane your neck a little bit and look at the page to figure out the relationships, right? So, what's the measure of angle 1? What's the measure of angle 2? So let's look. We know this is 120. Okay, I always start with the one that's easiest to do. I'm noticing that this 120 and this angle 1, they're corresponding. How do I know that? Well, they're in the same location in their different neighborhoods. Angle 1 is in this top neighborhood, and the 120 is in this bottom neighborhood. They're both in the top right corner. So I would say angle 1 is 120 degrees. Why? Corresponding angles are congruent. That's my justification. Okay? Let's look at angle 2. Angle 2 and this 120 are supplementary. How do you know that, Mr. T? Well, they are same side interior angles. They're on the same side of my transversal Q, and they're inside my lines A and B. So I would know that 120 plus angle 2 equals 180. So with a little subtraction, 180 minus 120 should give me angle 2. And it does. It gives me the 60 degrees. How did I get that? Whoops. Same side interiors are supplementary. Okay? Now notice these examples only covered corresponding and same side interior. You might be prompted to use the other relationships. Alternate exterior, alternate interiors, or same side exteriors. And maybe you could even use a vertical angle or two if they pop up. You just have to pay attention to what you're given. Okay? Let's go down here to C. We still got an angle 1 and angle 2 defined. So let's do the measure of angle 1 equals that. Measure of angle 2 equals I don't know. So let's look at this picture. You're probably thinking, what's wrong with you, Mr. T? There ain't no parallel lines in that picture. Oh, yes, there is. I see a pair of arrows, don't you? But you're thinking, those aren't lines. Those are the sides of a four-sided figure. Well, you all shouldn't be too much of a stretch to realize that, hey, I can extend these. Let's extend our sides that are called parallel. Right? And you might want to extend the other sides too, because so remember, these are the ones that are parallel, the ones I'm drawing the arrows on. These other sides are going to serve as our transversals. Okay, so let's look at what we know. We know that's 80 and that's 70. Okay, sorry, my neck was craned for a minute. I didn't have to. This line and this line are the parallel ones. So this line where the 80 is at, that's one transversal, and this is another transversal. Okay, I'm noticing that this 80 and this angle 1 are on the same side of a transversal from A to D. They're on the same side of the transversal, and they're inside the two big lines. Those would be same side interior angles. So I know that 80 plus the measure of angle 1 should get me to 180. So I'm just going to subtract 80. What's 180 subtract 80? That's 100 degrees. What was my justification? I know that same side interior angles are supplementary. Okay? And now we're going to find this angle 2. So now angle 2 is on this transversal. So the angles are going to be a little bit different. Okay, it's a totally another transversal, so ignore what we did over here with 80 and 1. This 70 and that 2, I'm noticing they're both inside those two angles, or two lines, excuse me, they're in between those two lines, and they're on opposite sides of this transversal from B to C. That means they are alternate interior angles. And we know from earlier that that kind of relationship is congruent. So we're going to say angle 2 is 70 degrees. How do we know that? Because we know that alternate interior angles are congruent. That's all there is to it. Okay? I think that's it. So let's go on. Oops, backwards. Sorry. Okay. I had to see how much we had left. All right. Because I've been talking a long time. Oh, yay. Now we're going to use those relationships we just talked about. So we got to keep them all in our head. Remember how they work. And now we're going to throw some equations into the mix with a little algebra. Okay? So we're just asked to find x and then to find the each labeled angle. So basically, find the x and then go plug it back in. Let's look at this first one. We've got x plus 40 and this x, and it looks like we're inside a trapezoid. So what I'm going to do is I'm going to extend my parallel sides just for a second. And then I noticed that those two angle measures are on this, they're closer to this line, so I'm going to extend that one because that is my transversal. So we're going to look at what relationship we have here. The x plus 40 and x, they're inside these two lines. So we know we're talking about an interior situation. And they're on the same side of my transversal T. I'm just going to call it T. They're on the same side of my transversal. These are same side interiors. If you want to label like that, you can. What's that relationship? We know they equal 180. So what we do is take x down here, add it with x plus 40, and it should equal 180 degrees. All right? And now we're going to combine like terms. Subtract 40. So I got x to be 70. Okay, so that fulfilled the first question, find the value of x. The second part says, then find the measure of each labeled angle. So basically, I'm going to take this x and plug it back in. Well, down here, duh, that's 70 degrees. If I plug 70 back up here, I would get 70 plus 40, which is 110 degrees. And if you notice that 110 plus 70 is indeed 180, so we've done our work right. We know we did it right. Okay, let's go over here to this triangle. We've got parallel lines right there and right there. This x plus 40 is going right here with this angle, and we know what that angle is, so I'm going to say that is our transversal. So let's look. Okay. It looks to me like we're talking about a corresponding angles situation. How do you know that, Mr. T? Well, it looks to me like 3x minus 10 is in this bottom left corner on the top neighborhood, and then x plus 40 is also on the bottom left of the lower neighborhood. So it looks like to me we've got corresponding angles going on here. What's the relationship between correspondings? They're congruent, which means they're exactly the same. So we're going to take our two expressions and set them equal to each other. I'm going to move this x over here. And I would divide 2 there, so I would get 25. So I have found my x. Funny, found my x. Sorry, I'm a dork. Anyway, I got my x. Now, I have to go plug it back in. So, x plus 40, that would be 25 plus 40, which gives me 65 degrees. Now I got to do 3x minus 10. So 3 times 25 minus 10. 3 times 25 is 75. 75 minus 10 is 65 degrees. Hey, these match, so we know we're correct. Okay? I hope you're picking up on how important it is to understand what those relationships are. The correspondings, the alternate interior, alternate exterior, same side interior, and same side exterior. You've got to know what they are in order to solve these kinds of problems. Okay? So let's go down here. I'm going to erase what I've got up here because I have to work up here. I don't have a lot of room. All right. I'm going to do letter C in red. Where's my parallel sides? They are right here. Don't you just love a straight line I draw? And then notice that they're those 4x and 5x are down here. So I'm going to let that be the transversal. So if I crane my neck, it looks to me like we have another same side interior situation here. They're on the same side of this transversal that I'm going to call T, and they're inside my two major lines. Okay? So same side interiors mean they are supplementary. So I'm going to take 4x plus 5x and equal it to 180. Let's combine like terms to get 9x, and then we're going to divide that 9. X equals 20. So we've got what x is. Now we're going to plug it in. So 4x is going to be 4 times 20, which is 80 degrees. And then 5x would be 5 times 20, which is 100 degrees. And if we want to check ourselves, what's 100 plus 80? It's 180. So we did our work correctly. Right? Last one. Let's do my favorite color. Now, we know which ones are parallel, right here and right here. So this is our transversal. We're given this box and an expression. What's that box, Mr. T? Doesn't that look like what that means, 90? Why, yes, it does. That box tells you that angle is 90 degrees. Okay, that's just the thing we got to know. That box means 90. So what's the relationship between this box and this expression down here? It looks to me like we're talking about a corresponding angles situation, because this 90 is in the top right of this upper neighborhood, and then 3p minus 6 is also in the top right of the lower neighborhood. So we're going to take that 3p minus 6 and set it equal to the 90, because corresponding angles are congruent. Now we're going to add 6. I think that's 32, but I'm going to double check because I'm not sure myself. Yep. Okay. Now, I got to take this p, plug it back in here. So 3 times 32 minus 6, that's going to give us 90 degrees back. Okay. I think that's all I have. So again, it is crucial and so important that you know those angle pair relationships that we talked about earlier, the corresponding, all that stuff. All right. So let's look at what's your homework because I forgot to add it. Okay. 1 through 7, 8 through 13, and 14 through 16. Okay. If I'm thinking correctly, 1 through 7 is going to ask you to identify the relationships. So that's corresponding, alternate interior, that stuff. 8 through 13, you're given one angle measure and you have to find a couple of others using those relationships. And then 14 and 16 is like the last example, using some algebra to do it. All right, that's all we have on properties of parallel lines. If you need help at all with understanding this content or any help at all, don't hesitate to ask. I'm here to help y'all.